Part D. Now there's a couple of stars next to this because this is a particularly challenging problem. This question says, find the constants m and b for which y equals mx plus b is a solution to the differential equation. Okay, so first of all, we have our differential equation, 2x minus y. That is an equation for slopes. I've kind of highlighted that there. And this is not separable, so we can't actually solve it algebraically. So it says that y equals mx plus b is the solution to that differential equation. Well, if that's the case, then that means that the coordinates on y equals mx plus b must be a point also on that function. So I'm going to start with y equals mx plus b, and that tells me that I have a coordinate at 0 and b on the solution equation. Okay, that must represent a point on the y graph, which is the solution. Okay, so that's the first part here. And what I want to do then is, what I can do is, if that's true, then that point will also calculate the slope. So that's what I'm going to do then. I'm going to calculate my slope. So I'll write it out this way. So dy by dx, which is a slope, at the coordinate 0 and b is going to calculate slope of that equation. So we're going to plug in 0 for x minus b for y, and that's going to be equal to my slope m. And what that does then is I end up with this fact that negative b is equal to m. So at least I have the m and b in terms of each other. So this is very useful because I can then plug that back into my original solution equation. I know my solution equation must be y equals mx. And then instead of b, I'm going to use negative m, so minus m. Okay, maybe I'll write it out this way so I can see that it's a little bit clearer. So this turns into b equals negative m. So we get mx plus b, which I'm going to replace with negative m. So what that's done then is at least it's gotten rid of one of the variables to solve for. M, I had m and b. Now I just have m to solve for, but I still can't solve for it based on that, what I have here. So this is a little bit of a problem. However, I do have this other relationship up here originally, and I know that this y and that this y here are the same y's. So what I can do then is what I can replace one y with the other, or express one y in terms of the other, and then I can see what happens here. So I'm going to start with my 2x minus y, which I'm going to put in brackets like that, is equal to m. And I'm going to replace that y with the mx minus m. So this becomes mx minus m. And the reason why I'm doing that is because these are different. I've generated these relationships from different parts. So if I combine them together, hopefully I can come up with something new. So what I've done here is I've come up with something new. Now it doesn't quite look like something I can use yet, but I'm going to make this equal to 0, combine some like terms here. So I'm going to end up with 2x minus mx, and then this becomes plus m minus m. Well, at least those m's cancel out, and that's equal to 0. And I end up with 2x minus mx equal to 0. Now, again, I can't solve for this. However, it is factorable. It is equal to 0. And if that's true, then I can factor and try to solve for x and m. Well, I don't really need x because x is a general variable. But when I factor this allows me to solve for m. And if I can solve for m, I'm partway through to solving for that general equation. So here m is equal to 2, and that's really important because I can now use that in the m in the original equation. Not only that, I also have an equation that allows me to convert m's to b's. So if m is equal to 2, then that means that b is equal to -2. And given those two values, now I've solved for m and b of my general solution. So the general solution to this equation is y equals m is 2, mx plus b is -1, -2. So 2x minus 2. This then represents the general solution that I'm looking for, which I had stated originally. This is a general solution that we were looking for, and we found the m and b that fits into that equation. So again, this is a particularly challenging one. There's some parts here that were really we had to identify before we could solve it. First of all, being able to identify coordinate 0 and b, being able to find the equation for m in terms of the 0 and b, which allows us to relate m to b, and then lastly, to be able to combine the y equations to be able to solve for that m value.